meaning to be in the breaking ground track, then perhaps you should go find another track. I'd like you to welcome today Will Schroeder and Justin Warner from Verus Group to talk to us about some PowerShell foo and good stuff. Gentlemen.
Woo! Yeah. This is building an empire with PowerShell. This is our super awesome little, totally not ripped off from Star Wars logo that we have with the PowerShell thing inserted into it. So. But first things first, before anything else, this project is heavily built upon the awesome work of a lot of other people. A big thing with Empire is that we want to weaponize and bring a lot of the offensive PowerShell work to the rest of kind of the wider pen test community and bring it to everybody in a way that can be really easily used in operations. So because of that, a lot of the modules and underlying stuff in the background is built on work from especially Manifestation and ObscureSec, the PowerSploit project, Carlos Perez, Dark Operator, Lee Christensen, Tifkin actually built some really cool .NET in unmanaged code spaces type stuff that we use for injection. You know, Ben 10 in WJ computing, and our Enigma OX3, our ATD Padawan, the rest of the awesome offensive PowerShell community. We love you guys. So my name is Will Schroeder. My handle is Harmjoy. I'm a security researcher and red teamer for the Adaptive Threat Division of Verus Group out in Northern Virginia. I'm a co-founder of the Veil framework, so Veil Evasion, if any of you guys have used that on engagements. I wrote a big chunk of that. I'm a co-founder and developer on Power Tools, which is a set of offensive PowerShell kind of scripts and projects. I work on that with Justin. And I've talked at a few cons, ShmooCon, CarolinaCon, DEF CON last year, DerbyCon, but BSides Las Vegas is definitely one of my favorite conferences out there. So.
I'm Justin Warner. So I joined Verus Group about a year ago. I'm the red team capability lead, so I do a lot of our advanced engagements against commercial customers. I'm also working with Will on Veil Power Tools. I spent a lot of time developing that. Did a little bit of work on the Veil framework. I have a lot of varied interests, so I bounce between reverse engineering and defensive stuff, but I also like studying and using it on the offensive world. You can cat a lot of the same stuff that Will said. We do a lot of the same work. If you're interested in talking about what we do or looking for a job, please definitely hit us up. So we're going to be going over lots of different things today. We're going to kind of start generalized and go through offensive malware or rats and how you use them, some generic characteristics about them. And then we're going to dive straight into how we actually use these thoughts to build our own rat and put it out for public use. We're going to roll through some modules that we built. I think we're up to 90 now. And demo the tool, as well as talk about how to take it down. We try not to do too much offensive stuff without providing some defensive guidance or tell people how they could stop it, should they see it in a real environment. So we always kind of start our talks with prepend them with a red team philosophy. And so for us, red teaming means a lot of different things. Different groups do it different ways. Some people focus on physical operations. Some people focus on integrating different things. We primarily focus on training defenders. And so whenever we do red team operations for us, we want to provide a service and we want to provide skills to defenders in their own environment. So it's a pretty key thing. Let defenders learn in their own environment with their own tools so that should a real thing happen, they get to use it. This plays into Empire specifically because one of the main motivations for us writing it is we wanted to train defenders in stopping PowerShell attacks in their own environment. We do assume breach, so we don't necessarily always focus on that initial exploitation vector. We focus heavily on post-exploitation and the actions of an offensive person once they're in the environment. And so you'll notice a lot of the modules we do, or a lot of the work that's been done in this tool, is mainly suited around making this usable as a post-exploitation agent. So why write malware? Well, previously we had been using commercial tool sets entirely. We never wrote any of our own stuff. We really didn't have much of a development framework. Will did a lot of work on the PowerShell side doing PowerView and some other tools, which kind of segued well for us and made it easy for us to transition to actually writing our own agent. Ideally, the first reason we started doing this was because we showed up on an engagement, and within the first day, we popped like 237 alerts. And they're like, well, this isn't really training for defenders because they called us in the first hours of the engagement. And so overnight, we had to stop and figure out how we were going to do some sort of custom work on this engagement. And for us, we had kind of had this drafted, but it even more motivated us to continue the work. Some other reasons, who doesn't want to have a dream rat with all the capabilities their team actually uses as opposed to having to adapt to other tool sets? That was a big player for us. And then when we started seeing things like Powellix come out or other PowerShell variants, or PowerShell being used in the evil APT attacks with macros and all sorts of other things. We wanted to see if we could really center on training the good guys how to stop this. And for us, that was actually building our own malware with it and deploying it in environments where we're operating. So lots of people will bash on offenders or offensive staff. They say, why aren't you using all your skills to do good things instead of bad? We try to really focus on the union between the two. We believe that offensive and defensive are together, especially in the red team spaces. And so without a little bit of practice, you never know how you're going to actually square off. Nothing we're releasing here is super mind-blowing. It's not going to evade any of these crazy network products. It's not the next generation rootkit. It's not a Stuxnet level thing. We're releasing something that's realistically meant to be used by red teams. It's overly easy to stop once you actually start performing some analysis on it. And we built it that way. We built it to encourage defensive people to actually go in and do the analysis and reap the rewards should they actually do that.
Cool. So offensive PowerShell. This is one of my favorite quotes from ObscureSec from the PowerSploit project. He likes to call PowerShell Microsoft's post-exploitation language. It's supposed to be meant as kind of a system automation and a management type framework. But once we really started to get into it about a year and a half ago, it's been awesome for our operations. It's really changed the way that we focused and operated on engagements. So why use PowerShell? If you are a pen tester and you're not using PowerShell in current engagements, I would highly recommend checking it out, considering integrating into your workflow. So PowerShell provides out-of-the-box full access to the .NET framework in the backend. You can actually think of PowerShell.exe essentially as a wrapper for the .NET automation components in the backend. So you can do things, you can create web clients, download stuff, access anything you could in the full .NET stuff. You can kind of implicitly get by some application whitelisting unless people explicitly started locking down and targeting PowerShell, which we can kind of talk about after if you're interested in that type of thing. You can get full direct access to the Windows 32 API, and you can assemble malicious binaries fully in memory. And going through a lot of these components, we realize you can write fully functioning malware in PowerShell without using anything else, which is essentially what we've done with Empire. There's a great post called Why I Chose PowerShell as an Attack Platform by Mac Raber, one of the PowerSploit authors. I encourage everybody to check it out. And also, a lot of bad guys are using PowerShell. So a lot of nation states, even though they typically have had like C and C++ agents historically, a lot of the APT groups and even some of the more mid-level actors have started integrating PowerShell into their attack flow. PowerLix was a really interesting pure PowerShell variant that came out over the last year. Deep Panda was known to use PowerShell in breaching think tanks. The APT29 actor, which Mac Raber talked about this morning through WMI, they also integrated PowerShell in a lot of their attack sets. So if you read a lot of these threat type reports that examine specific actors, a lot of the more advanced ones over the last 2 years, if you read through the tradecraft section, you'll actually see that they have started to use PowerShell more and more and more. Typically, it's been for kind of like a loading component to actually load up the rest of their agent, but some of them have started to use the pure offensive capabilities of PowerShell more and more. So existing stuff that's already out there in PowerShell. The PowerSploit project offers everything from screenshots, key logging. There's the equivalent of incognito called Invoke-Token-Manipulation. And of course, everyone's favorite Mimikatz, which we'll go over later in the project, later in the presentation. There's a pure PowerShell implementation called Invoke-Mimikatz. So any function that you can use in Mimikatz, not just grabbing passwords, but Kerberos and everything else, you can do purely in PowerShell while staying off a disk. PowerView is a tool that I wrote, which is a networking domain situation awareness tool, which heavily factors into a lot of the modules in Empire. PowerUp is another tool I wrote, which is a privilege escalation kind of automation script, which will check for common priv-s vectors. PowerBreach is a tool that Justin had written that kind of has some additional like in-memory type of persistence mechanisms that are really interesting. And POSH-SecMod by Carlos Perez has a lot of like Active Directory and post-exploitation stuff. So while there's a whole lot of really awesome tech out there for offensive PowerShell, one of the things we started to notice is the weaponization problem. So if you're on a pen test, how do you actually execute these PowerShell scripts and get the results back in a secure manner? How do you trigger it? That's the biggest problem that I've seen that's caused the lack of adoption of offensive PowerShell by the general pen test community. So using the existing PowerShell stuff at this point also hasn't been super straightforward. This execution policy stuff, whether you have to RDP in, whether you're doing a one-liner with a download cradle and people aren't familiar with it, the fact you have the pipeline, the fact you have to format your output, the fact that you have all these weird little kind of subtleties with PowerShell, that once you learn them, it's not too much of a problem. You kind of know how to operate with it. But at the time, that kind of little learning curve it can be an issue. So this is the problem we're trying to solve. We want to solve the weaponization problem so we can bring all this offensive PowerShell tech to everybody to use, even if you don't know how to use PowerShell. So looking at all this PowerShell stuff, I thought about 9 months ago or so, you're like, well, weird, keyloggers and Mimikatz and screenshots. Like, these are all the functions and capabilities of a rat. This is everything you're going to have in interpreter. This is everything you're going to have in, whatever your kind of agent of choice is. Why hasn't there been a pure PowerShell rat at this point? Everyone tends to use these scripts as kind of augmented capabilities, but there hasn't been a pure PowerShell remote access tool variant that actually integrates all of it together.
So when we first started kind of going down the development path, the idea spurred, Will came to me and said, I think it would be really, really cool to do this. And I was like, well, let's figure out exactly what we want. And so I did a lot of work doing reverse engineering of malware, previous job. And so I'd seen a lot of different stuff. I'd seen all different variants of malware, crimeware, loaders, rootkits, injection capabilities. And I'd seen it all implemented in a ton of different ways. And we really wanted to boil down to a couple unique requirements or unique things from that that we felt it was important to have in a rat. So, what was actually operationally important to what we were doing. So we like to distinguish between a rat and a backdoor. For us, a rat is focused on the actual interaction and control of a end-user system. So the endpoint that you're actually controlling. The center point for us was not necessarily persistence or how you were going to get rebooted or how the in-depth work was going to, doing injection. They all played into it, but we wanted to focus on control of the system and collection of user data. When you start thinking about that, there's all different things that come into play. Here's a list of a bunch of them. We could go on forever, all the different factors or characteristics that play into a rat. You can look at all these same things when you look at Meterpreter or commercial frameworks, whether it's Innuendo or Cobalt Strike. They all implement these central themes. So, starting with the staging problem. Staging is the idea that traditionally, malware will deliver a very small stub to the target initially. This is for lots of reasons. Number one, that stub is usually going to be very vulnerable. It could be captured, or it could be caught by an antivirus or some sort of host-based IDS. And you don't want your full agent to be the thing that gets caught. You want to start with some sort of loading capability. The staging problem is what we call the issue where how do you deliver your full agent to either memory or disk in a secure capability. Meterpreter, before it had all the recent additions, had a lot of problems with staging. A lot of most common antiviruses had started to signature the user agents and the resources that were involved, and so it was very tough to use. And you don't want that to happen. You want variance, and you want the ability to change that. And that plays into the staging problem. It can be very noisy in a network. If you have a 2 megabyte agent, that stager is going to have to download 2 megabytes. And that could flag in some cases. It depends on how secure the networks were. We mostly work in fairly mature commercial networks, so places that have a very mature SOC, incident response capability. Some of them have full-on hunt teams where they're actively prowling the network looking for bad guys proactively, meaning that we had to be conscious of all of this when we were implementing these different characteristics. Next slide. The next step, so you deliver a stage, you deliver your agent, command and control. How do you actually want to communicate out of the network? We do a mix of black box external assessments as well as internal assessments. So for us, it was a definite requirement to have whatever we did had to be able to communicate outside of networks with strong boundary protection. So these include things like proxies and firewalls and IDS. We wanted our capability, we wanted any capability we were even thinking about developing to be able to work through this. There are tons of different comms methods out there. Most of them have open source variants that do this. So HTTP, HTTPS are the most common. If you look at any modern rat, they communicate with those mechanisms because, well, all users browse the web unless you're in a closed-off network. And then SMB usually is a really great feature because it allows you to pivot peer-to-peer internally, and so you don't have to worry about having 100 egress channels. It's also very tough to implement in a good, correct, secure way. And so this was a lofty requirement to kind of lump in at the beginning.
That's part of our future kind of roadmap down the road.
Sure. And then survivability is really the key feature throughout all of these characteristics. Is can it live in the environment? Is it stable? And is it going to persist without throwing those 237 alerts like we had in that first environment? For us, another big motivator was on that same engagement where we had to rapidly dev our own malware. We also reverse engineered a custom solution that was present in the environment. And so there was a piece of software that was present on the standard image of every workstation in this customer environment. So when we reverse engineered it, we found a vulnerability in this software that allowed us to gain access as an administrator, local administrator, on anything that was running the standard image. So it was great. We found a vulnerability. We wanted to weaponize that into our attack platform. And since we didn't really have an attack platform anymore because it got destroyed on our first day, we decided that a key feature of our framework or our agent was going to be the extensibility, the ability to rapidly develop modules and put them in without having to stand down your communications or stand down your tool. We wanted it to be easy, so we wanted it to be anybody who could take a PowerShell project that already existed or write their own PowerShell project, could implement it in the RAT, since this is a pure PowerShell post-exploitation agent.
Cool. So Empire is the result of all that dev. I know Justin said we were kind of motivated on some internal engagements where stuff got burned. This has been about 9 months of pretty solid dev kind of in the background. So this isn't a one-off script. We put a reasonable amount of effort into this. It's about 50 to 70,000 lines, something like that, and a whole lot of internal commits. So Empire is a fully featured PowerShell post-exploitation agent. Probably an easy way to explain to people in one sentence would be it's kind of like an asynchronous interactive agent like Meterpreter, but based purely in the PowerShell language. So the agent is running purely script-based, all in memory on a Windows host. It aims to provide a rapidly extensible platform so we can integrate all this awesome offense and defensive PowerShell work. Again, this is our hopeful solution to the weaponization problem. Just like Justin had mentioned, it's also our attempt to train defenders on how to stop and respond to PowerShell-based attacks. We also like to have agent variability. So if we're on an engagement against a mature team, we like to be able to use commercial tools, go back to Meterpreter or use something like this, and vary our types of lateral spread, communication, and agent comms whenever we're in a network. So in case one thing happens to get blocked, our entire engagement doesn't get torn down. So a lot of people have written off PowerShell. So some people have referred to it just as a toy language. There's a lot of people that basically say if you're not writing your agent in C or C++, then it's not real malware. And a lot of people have said, with AppBlocker, with Windows 10, and all these types of things, it's going to be easy to block and defeat PowerShell, and it's not really a big deal anymore. This has caused a lot of incident responders to overlook it as a malware vector. Also, all the miscommunication with Microsoft about execution policy and sysadmins thinking it's actually a protection mechanism has also contributed to this. So we wanted to provide an agent that you can use almost as a proof of concept to people of saying, look, PowerShell is a big deal. It's not just a one-off toy language. You can write real malware with it that can inject into different processes, which we'll go over. And you can do anything you could in something like Meterpreter pretty much, purely in PowerShell. So the server side, so kind of the control server. This would be the equivalent of like our listening post. We have a client-server architecture. The server is written entirely in Python, multi-threaded handlers in the back end. And the little client staging code is written entirely in PowerShell. It's modular and it's kind of multi-part. So we have key negotiation, like crypto, a packetized structure, and everything in the back end, which we'll go over. There's a back-end database that preserves agent and listener configuration. So if everything crashes for some reason, you bring it back up, your listeners will start back up. And because the agents are asynchronous, all your agents will come back in. So even if they can't reach the server, they're not going to close off or error out. And everything is logged very, very extensively. This is a really big deal for us on red teams for deconfliction and also, like artifact recreation for blue teams at the end of the engagement. So there's a log per agent that has timestamped taskings and results for everything the agent does. Anytime you upload a file, it's going to MD5 the file and give you the original location as well as where it's uploaded to. Anytime you download stuff, it's going to give you the full original path. Basically, we wanted to go, as in-depth as we could on logging to provide as much data as you can. There's even more if you want to do --debug. That'll dump, the individual taskings and communications and all that kind of stuff in the back end. But even just by default, there's an agent.log for every single agent that checks in that has, kind of our logging on crack pretty much. So that first step that Justin kind of talked about previously, execution. Somehow you need to get your agent executing in memory or on disk on your remote host. Traditionally, this has been a lot of exploits, using browser exploits, client-side Flash-based stuff. We don't really use exploits an incredible amount. We use a lot of user-driven attacks. We use our signed Java applets, we use our macros, we use our OLE embedding, and we use user-driven stuff that's not exploit-focused because we find it a bit more reliable. But regardless, you need to have a way for Empire to execute a small PowerShell command that can load up the core component of the agent. So we have different kind of stager formats as kind of an extendable modular type of setup. So we have VBS stuff, we have macros, we have self-deleting BAT files, we have single commands, we have ducky scripts, and we also have a reflected DLL, which is pretty cool. So this actually forms the core of some of the process injection later on in the presentation. But we have a fully injectable reflective DLL that will stage up a Empire agent that's linked to the server. You can take that reflective DLL and you can use it in other exploit frameworks like Metasploit. So you can use the Windows DLL inject, reverse HTTP or something like that. Load this as your custom agent, your custom payload, and when you deliver some kind of exploit, you can have your exploit server on Interpreter and have it actually stage up Empire agents to a different control server. So the listeners, this is the server side of the whole system. You have configurations for the staged agents at this point. You can change these per listener. There's also a bunch of default values. You can all change this stuff in the backend database when it's originally set up. We'll go over a couple of these, the things later in the demo. I know this is pretty hard to read, but you have things like kill dates. So you can set the agents to automatically exit after a certain date at the end of your engagement. You can do working hours. If you only want the agent to communicate, 9 to 5, or you don't want it to communicate 9 to 5, you can have it essentially like sleep and shut down during specified time windows. There's default callback intervals and jitters and stuff. And there's also different communication profiles. So you can change, even per agent, what the tasking URIs are. You get a multiple different tasking URIs. You can change the user agents. You can add additional indicators into the headers of the different HTTP communications. So we wanted to make this as flexible as possible. And currently, there's HTTP and HTTPS comms. I know Justin mentioned we're hopefully going to do DNS and SMB in the future. Other additional listener stuff, little tidbits. You can dynamically set whitelist and blacklist for IPs. So if you're on an engagement and you notice there's like really pesky network defenders from a certain net block that have started poking your server or scanning you, you can basically block off their IP range and it'll just return a default page. Or if you're on an external engagement and you want to be very controlled in how you're doing phishing, you can have just IPs from your target organization be accepted to your control server. We're very risk adverse. We don't want stuff to go wrong, so we like being very controlled in how we do stuff. Again, the kill dates and working hours. You can also do foreign listeners to pass sessions between multiple control servers. So you can have multiple Empire servers, set a foreign listener, and actually have different people that are geographically disparate pass sessions to different control servers. You can also pass inject shellcode to pass agents to something like an interpreter listener that's on a different host. So the Empire staging. This is when you initially trigger a small little one-line snippet that's kind of a souped-up version of the PowerShell download cradle. What it'll do is it'll request a specific URI that you can customize. It's a static value. It's going to return back a obfuscated little chunk of script. This part is just it's just XOR'd. We're assuming people are going to be able to decrypt it. We're assuming this initial AES negotiation key is going to be burned or recoverable by defenders. What will happen is the server will return this key negotiation code, this XOR'd. The client will decode it, run it in memory. That key negotiation stub will generate a public-private key pair. That stub will take the AES negotiation key, encrypt the public key, post it back to the server, The server then takes that public key and then exchanges some stuff with like epoch time for synchronization, and also a randomized AES session key. After this, the communications will start. And the point with this is it's something called encrypted key exchange. It provides something called perfect forward secrecy, so even if defenders are doing a full PCAP of all this, they can't recover the randomized AES session key per agent. And then also each AES key is different per agent, so if someone does do a memory analysis, they won't be able to decrypt everything in your entire mesh. So this, is this still me? The C2 in the backend, it uses a lot of these .NET methods in the backend to actually do the HTTP or HTTPS communication. It's the net.web client. If you guys seen the little IEX new object net.web client thing, that's the same type of primitive that's used in the backend. Again, there's nothing too magical here. It uses a get and post type structure, so the client's going to periodically do get requests. If there's nothing that's tasked, then the server is going to return a default page. That's, again, this is customizable if you want to do some other kind of default page. If there is tasking, the server is going to return an encrypted blob that's encrypted with the AES session key specific for that agent. If there's results from the agent, it'll post encrypted stuff back. We do cipher block chaining with randomized initialization vectors, and it's the fully packetized structure underneath. And we're not saying we did the crypto completely right, but we thought a lot about it, and we tried our hardest to do it reasonably correctly.
Crypto is hard.
Crypto is very, very hard. Everyone says don't roll your own crypto, and then we tried to roll our own crypto. So if you guys find a problem with this, please, please, please let us know. Don't just pop our servers or something. So once you actually have your interactive execution with agents, it's essentially kind of like an interactive remote PowerShell prompt. So you can run any PowerShell code that you normally would, any of the commandlets like get-process or something like that. Or you can run any typical shell commands. You can cd, dir, ps, ls, all that type of stuff you're used to with normal shell commands for an agent. You can also upload and download and all those the types of things you would expect from a normal rat. We also have the ability to import specific PowerShell scripts. What this will do is it will take a obfuscated PowerShell script and stuff it into an encrypted block in memory for the agent. Then you can execute a particular command. The script will be decoded. It'll execute a command and get the results. This is for things like PowerView that we use a lot that have a whole lot of command lists that you want to chain together and just access specific functions. You can also build modules for specific PowerShell execution, things like Mimikatz, things like tokens. We'll go over the module section here in a second, and there's a whole lot of this in the demo. This is the whole, wanting to try to have a interpreter-style module type functionality. You can build this stuff out, even customize some things, and make it super easy to use without knowing how to pipe stuff in PowerShell.
So we're going to go through as many modules as we can. Obviously, with limited on time, we did develop, I think we're up to 90 modules. We have a bunch still private that we're testing and working on internally. So we'll be continuing to support and put out modules as we go. So worth noting that what you see there, please feel free to contribute if you are interested in this kind of thing. We love public support and public research on the project. PowerShell is traditionally something to get hard to get into, and so we're trying to spread the awareness and get people in love with it. Next slide. So like I said, about 90 modules, several more in testing. We focused more of our first round of modules on things that we actually needed to use in the engagement. Like I said, this was kind of spurred on by the fact that we had to develop something custom in a very, very short time period. And so most of the first modules we had were pulling together all the current projects, solving that weaponization problem, and integrating them into the agent so that we could use them fluidly in an operational environment. Again, we baited this in several real environments now with customers that we've had tougher times with. And so it's definitely not perfect. I'm sure there are issues, but it's been run through some pretty complicated networks, and it seemed to work very, very well in the real world. We're going to show some of the top used ones here. So there are tons of categories. We break it into categories so that it's organized. I'm a little bit OCD. And so I don't like the fact that modules could just be scattered about. When I first joined the project, Will's just like, oh, there's modules everywhere. It's just raining modules. And there's no names on them. They're like module 1, 2, 3, 4, 5, 6, 7, 8. And so no, we took the time to organize it, put folders around it, and try to make it easy to use and jump into. We're going to talk about some of these. It's worth noting that We kind of break it into the phases of an engagement too, and we always like to have a little, if anybody does like CCDC, we have a troll exploit category for you. You can have some fun with it. Don't use that in a real environment.
We may or may not have a module that plays Thunderstruck while maxing out the volume on your computer. So.
Yeah. Without actually popping a window, so you know, you can have some fun with that. So, module development. We wanted to make this very easy. So what we did is each module is essentially a Python metadata container. So it's a Python script, but there's not much set there. There's a template that you just take, and you set some variables specific for your module. So things like, does it require admin? What PowerShell version does it require? Is it OPSEC safe? For example, does it drop something to disk? Once you set those, all you have to do is include your PowerShell script. That's it. That's a module. And so any existing PowerShell functionality can be turned into a module and have restrictions set around it to work inside the framework. Our first module that we kind of ran into was, well, every defender who knows we're bringing a PowerShell toolkit is going to go looking for PowerShell. And so in CarolinaCon, about, I don't know, 5 or 6 months ago, we released a project called PowerPick. We didn't say it at the time. PowerPick was actually built to support Empire. And so PowerPick was essentially a project which allows you to run PowerShell without PowerShell. There are a couple major components of it. There is SharpPick, which is a C# binary, which allows you to execute PowerShell with C#. PowerShell never spawns in the back end. It uses all the .NET APIs. I took that, and we had a big Twitter discussion about whether this was possible to do inside like a C++ binary. A guy named Lee Christensen from Silent Break Security did this awesome project where he put out unmanaged PowerShell. It was a lightweight project written in C++ that actually implemented the .NET CLR completely in C++. So with his little executable, you could run PowerShell and, again, never start a PowerShell prompt. I took that and turned it into a reflective DLL, which made it injectable using a lot of common tools, and then wrote a script called Invoke-Psinject. It's built on PowerSploit's reflective PE injection. Again, I didn't do anything super original here. It took a lot of other people's projects. I like to make sure they get the credit, and stuffed it all together. What this essentially allows us to do is run a PowerShell script to inject a reflective DLL into a remote process, which will then run PowerShell in that remote process. So when we released it at CarolinaCon, there was like 0 interest. And we're like, because who cares, right? Like PowerShell and remote processes. Well, when you stuff it into a project like this, it means a lot more. And so here's a cute little diagram on how to conquer the internet. Basically, you have an Invoke-Psinject. It's a PowerShell script, which injects inside of an executable. That executable is now running a reflective DLL, which is reflective pick, which drops a .NET assembly in memory, which allows you to get an interface into the .NET backend, which then allows you to run PowerShell, something like a download cradle, or our initial staging code, which will then call out to the internet and pick up more PowerShell to execute only in memory. And so nothing touches disk here. You gain PowerShell execution and remote processes. And then we have to have the token meme, and this is our favorite to always do. So yes, it can get rather complicated. You're running like PowerShell and PowerShell and PowerShell and .NET inside of C, inside of processes that don't belong there. We recognize that it's kind of crazy. We hopefully abstracted it out. And there's plenty more work that can be done to make this more efficient or turn this into shellcode or do other things here. So one of the first times we actually got this built into the agent, Will was like, well, I want to see what this can do. And so he goes and he injects this thing into like 25 processes all at the same time. And we're like, well, this isn't going to be good. Definitely this thing's going to crash. Surprisingly, as you can see here, we actually have our PowerShell agent running an LSASS, an Explorer, and services, and I don't know, pretty much every standard Notepad process, and nothing crashed. The agent was pretty stable. The reflective DLL that we wrote that launches all of this was pretty stable. And what it allows you to do is, if that defender knows you are using a PowerShell toolkit, and they go kill PowerShell, you still win. And it forces them to actually look and perform a full analysis on a system. So all joking aside, this is going to force people to start doing proper, memory analysis. Instead of just killing or looking for encoded commands inside of PowerShell prompts, they're going to have to dump memory. They're going to have to go to work to recover scripts. So the next step, we use this in an external engagement, and we were like, well, oh crap. Users use UAC. That's been a solved problem for a long time in things like Meterpreter or a lot of other offensive projects. But when you're using pure PowerShell, when we first worked on it, there was no UAC version inside of PowerShell. And so what we had to do is we had to take a step back from the agent and work on some of the core capabilities. We built a bypass UAC version in PowerShell. Again, very little original here. We essentially took the Metasploit DLLs, which have been already developed, and we took the technique, which has been heavily blogged upon by the person who wrote it, and implemented it inside of PowerShell. And so what it allows you to do is it allows you to inject, using bypass UAC, it allows you to inject the DLL you need to inject to get into a high integrity context and spawn our initial stager. So using a lot of the same technologies here, reflective pick is essentially combined with bypass UAC to allow you to get into high integrity context after a spearfish, all using our agent. It's worth noting on the previous slide, sorry, we've tested up to 8.1 on this. We've had little situations where it's been flaky. We haven't been able to figure out what the flakiness is caused by. I'd say we're about 90 to 95% there in test environments with all the different service packs, Windows 7 and Windows 8.1.
And it should be x86 64 compatible for 7 and 8.1.
So if you see certain use cases where you're using it, again, we love Git issues, or we're going to learn to love Git issues, and we would love you to give us feedback on it.
So Mimikatz, you can't have a modern Windows rat now without using Mimikatz. And if you don't know what it is and you're a pen tester, obviously shame on you. It's everyone's favorite post-exploitation capability. It lets you do everything from pulling plain text credentials out of memory, which is what a lot of people use it for. But you can also do your Kerberos golden tickets. You can do your silver tickets. You can actually do pass-to-hash or over-pass-to-hash with Mimikatz, which is what Empire integrates in the back end for its pass-to-hash capability. You could do skeleton keys on domain controllers. Like, there's an enormous amount of functionality in Mimikatz that a lot of people aren't fully aware of, that we're hopefully going to try to build some modules for and make it super easy to use. And also, Empire has an internal credential model. It will automatically parse the results of Mimikatz output, preserve it in a credential model in the back end, and then you can reuse those credentials on additional modules. So if you dump a domain controller's ntds.dit, which we'll show in the demo, the KRB TGT hash will be saved in the backend, and then you can just specify a cred ID to the golden ticket module and have it fill all the information in for you. This is just what actually running the logon passwords module in Mimikatz through Empire looks like. You set it, you can hit execute, and we have a lot of those options that Justin mentioned specified in the module, so we can set it to say it will only run in high integrity context, so it won't try to task an agent with Mimikatz unless it knows that it can actually run it. All these results will come back, and then if you type creds, you can actually pull up all the parsed and saved credentials in the backend. So another step that's really common is lateral spread. Our favorite method for lateral spread is WMI. Pen testers have been used to using PSExec for a long time. PSExec is much, much noisier than WMI. You're creating a service. You might be dropping a little bat file loader to disk or something like that. We've actually been caught by clients with PSExec. They've written some custom signatures and given us every single machine we spread to with PSExec PSH. So WMI is our go-to. Luckily, there's a really nice native functionality for WMI in PowerShell. So we've integrated this into a lateral spread Invoke-WMI method. You can specify a listener and a host. It'll execute the little key negotiation stage on the remote host and load everything up into memory without touching disk. I think it's pretty easy to use. There can be a few subtleties with WMI, which if you're interested, we can talk about. But this is our kind of go-to lateral spread. This is what it'll look like, and we'll show this in the demo as well. See the module configuration up top. You can set computer name for whatever your target is. You set your listener name, and it's all tab completable. We had a big UI focus. You execute, and you can get a new agent coming in on your remote system for pivoting system to system without piping something new in through a different control channel. A lot of people are like, well, what about pass to hash? Even though there was supposedly a Microsoft pass to hash patch last year, this is still a really common vector, especially for domain accounts. So the KB 287.197, it doesn't fix anything with with domain accounts for relaying NTLM authentication. I know with some of the new Windows 10 OS stuff, they're trying to fix some of these components. We'll see if they actually do. It took them several years to even acknowledge the pass to hash was an issue, so I'm not too worried. So we'll use the Mimikatz pass to hash module in the background to actually execute this functionality. What this will do is it'll spawn a new process hidden, so it won't pop up to the user, and it'll be running with the specified credentials of whatever you filled in. You can then use the credentials token module to do like a steal token and steal the new authenticated token from the hidden created process and then go run around with whatever you want. Cool. This is what it'll look like, if we're up there. We'll show this in the, no, we won't show this in the demo, but up here, you have like dir of a remote machine, says access denied. We have the credential model, so you see everything saved up there. You can use the full use credentials, Mimikatz PTH, or we also have an accelerator for it, which is PTH and then a credential ID for that top one. And it'll inject everything into memory. It'll start this PID 932 for a hidden process. We can steal that token. This will inject the token stuff in the back end. And now we're running with the context of that user only with the hash completely through a PowerShell post-exploitation agent. There's also a rev to self. After you do your token manipulation, you can wipe everything back to normal.
So we were going to attempt the demo gods, but then we decided against it. So we got a video recorded demo. Sorry. Hope you guys still enjoy. We were going to be a little tight on time here. We're trying to cover a lot of material. And so we'll talk through this, and it'll show a pretty solid use case of an average workflow. Obviously, this can get really large. There's 90 modules. There's lots to play with. But this will cover basically gaining access to an initial system, pivoting off of that, hitting another system.
So this is the main UI when you start it up. You'll see the number of modules. Sorry, we're going to zoom in a second so you can see it. But you have the number of modules loaded, the number of agents, you have the number of listeners. The first thing we need to do is set up our listener. So we can set it for a particular name. This is an alias that can be used for lateral spread or whatever else, tab completed. We're not going to set our kill date or working hours. We execute it so it actually stands up a threaded HTTP server in the back end. Now we need to produce our launching capability. We were going to simulate a fish or something. Just for the purposes of the demo, we generate a self-deleting BAT.
We all know users click everything, so.
Yeah. We actually like to take the BATs a lot and do OLE embedding in a Word document with a different template, so it'll self-extract, run, and then delete itself off the disk. So I triggered it on a remote system. You see the initial agent coming back with the randomized session ID. You can actually rename these agents to whatever you want. So I'm going to rename it fish user. This will actually change the save folder and all the stuff in the back end. So the first thing I'm going to do is I'm going to use PowerUp to run all these credential checks to see if there's a method to privilege escalate on this agent. You see info, this is that kind of modular setup that we talked about. Again, you don't have to know really anything about PowerShell to use this, right? You get them, you send them a phishing payload, they run it. You can run this all checks in PrivEsc and PowerUp, and you don't actually see any PowerShell code yet. It's going to test stuff in the back end. It's going to kick off a background job, a full Jobified kind of method in the back end. And we see that the current user is actually already a local admin, but he's running in medium integrity, so you need to run a bypass UAC attack. You can use the module, or again, we have an accelerator because we use it so much. So bypass UAC, and then you can tab complete your listener name if you have multiple listeners. It'll ask you if it's OPSEC safe because this is dropping files to disk. So this is just, take a step back, make sure you kind of know what you're doing to the system. And now we get an agent that comes back. It's high integrity. You see here we actually have a little star for the high integrity agent, meaning we can actually do our really interesting post-exploitation actions. We can steal any tokens. We can run our Mimikatz stuff. I'm going to rename this agent as well. Now I'm going to run a PS to see who else is on the system. It'll take a second. Again, this is on like a 5-second reachback interval, so again, full asynchronous tasking. We have the architecture and everything broken out. We see there's this other user, this TestLab DFM on there. We're going to run the psinject module that did everything that Justin talked about. Of all of our options. Now we execute this. This will send down a PowerShell script to the current running agent. That script will inject that reflected DLL into the target process. That reflected DLL will load up all the .NET runtime, which will then kick off our little PowerShell key negotiation code. And now we have a brand new agent running in CMD, running under this different user context.
DFM's our boss, so of course he's high administrator access in the domain because he's the boss.
Again, here, with all the UI focus, you see all that stuff that pops up. Everything is tab completable for all the modules, so I can use situational awareness and tab. We have broken into host and network. So the next module we're going to run is find local admin access. What this will do is take your current user token privileges and then query the domain for all machines in the domain and try to open up the service control handler in every single one of them and quickly close it. It's pretty noisy, but for the purposes of the demo, it can tell you exactly where you have admin access on the rest of the network very, very quickly. So we see we have access to primary.testlab.local. Now we're going to do our lateral movement. We're going to set the computer name to primary. We're going to set the listener and tag complete to our current listener, execute it. This will task everything in the back end to, from your initial pivot, run a WMI command to the remote machine, which will trigger the staging code and get a new agent running in a high integrity process coming back under primary. I'm going to rename this guy to DC. It's actually the domain controller in this test environment. Now I'm going to extract all the user hashes on the network, the ntds.dit. I'm going to use credentials Mimikatz. There's a lot of them broken up into different functionality, logon passwords, LSA dump, golden ticket. If you use the LSA dump, it'll dump all either the LSA in a particular host or the ntds.dit on a domain controller. If you just want a specific user like KRB-TGT, you can specify that. This is a pretty small domain, so we're going to show just all this data coming back. So all the hashes. What we do with this output is we actually just save the KRB-TGT hash for any database dumps that come back, so we don't have 5,000 people in the back end. Now I'm going to go back to my first unprivileged user, show that if I try to dir the domain controller, I get an access denied.
Because you're unprivileged at this point.
Now I'm going to use the golden ticket module. Look at the info, and you see this cred ID field up here. So I can set cred ID to whatever that KRB-TGT credential ID is for the credential model in the back end. That'll fill in the curb hash, the domain SID, and all the information you need for a golden ticket, essentially catalog. I'm going to set my user to say I want to be administrator in this domain. I'm going to execute it. This will task me Invoke-Mimikatz in the back end, build your golden ticket, your golden TGT, inject it all into memory, get nothing's touching disk. I think we should get the Mimikatz output here in a second. Yep, so golden ticket for administrator created. Now if I go back and just do my shell command to say dir, the domain controller. I have my persistent access again. So I could redo my lateral spread if I wanted to. I could data mine. I could add a user, do whatever I want.
Thank you, Benjamin Delpy. So we knew we were going to be a little tight on time here, so we might move a little quick. The slides will be up. They're already up on SlideShare for reference, so as we keep going here. So how do you detect it? Well, just like every other it has a lot of similar characteristics. Of course, it's a little less proxy aware because it's relying on system proxy credentials that it gathers from Windows. And so if you have any sort of really tight restricting proxy that uses like manual credentials to be punched in, or things are not stored via the system cache, this thing might bounce against the proxy a couple times. Really good way to pick up malicious things that are not making it out of your network. Really stand out, something worth noting. High entropy byte strings, so there's just random encrypted blobs in plain text HTTP. We've seen network heuristics that actually catch on this in very tight environments. Usually it has to be some sort of very large cloud product to catch something like that, but it will flag on our comms in this case. And then our favorite way to do is on endpoints. You're loading .NET assemblies and all sorts of Windows processes that don't normally load .NET assemblies. And so there's heuristics that could be written here to kind of start preventing and guarding yourself against .NET. So, like this. I don't know, if LSASS is hosting the PowerShell commands, .NET assemblies, it's probably pretty strange. I would recommend you calling incident response. If you do memory analysis on this guy, right now we have 0 obfuscation on the script in memory. We did this on purpose. We want incident responders to do memory analysis. And so we leave this all plain text, both the stager code as well as the full agent. You do a memory dump on this and do a strings, and you set the right strings length. You're going to recover the full agent in memory. So what exactly will that give you? It'll give you the AES keys and this giant nasty thing. You'll notice that we do camel case and all sorts of weird casing here. We do this to try to prevent any automated detection. Our goal is to prevent automated detection and to encourage defenders. With the AES key, they could then decrypt network traffic. So when Windows 10 started talking about PowerShell, Will about quit his job because he thought hacking was over forever because PowerShell was going to be stopped. I will say
it's not like we're giving a talk in a PowerShell agent, and then 2 months before Microsoft actually implements PowerShell defenses for the first time in 7 years.
we are really happy with what we've seen. We've done a lot of testing with Windows 10. Microsoft did a great job actually starting to build in and really focusing on PowerShell. It's their really first acknowledgement that PowerShell could be used by really bad guys and that users were having a hard time with it. So they did a great job. There's actually 2 main features. They added a crazy amount of logging, and then they added something called constrain mode built in App Locker, which prevents you from using all the .NET resources. We've done some initial testing. We've been able to get around constrain mode slightly because we think that it's built on the PowerShell.exe process and not on the .NET backend. However, it greatly complicates the attack chain. Our one feedback would be that who knows when clients are actually going to start turning on App Locker or using Windows 10, because let's be honest, we still see 2K3 in environments.
It's probably realistically going to take at least 2 years. And best case scenario, before large enterprises start implementing, large Windows 10 rollouts.
As we start testing this and working with it, we'll be sure to keep it up to date on the website with what we know it's compatible with and any work we do with Windows 10.
But it's not the end of the world.
Believe it or not. So the future, what do we want to do in the future? Well, we put up a PowerShell website for this. We want it to be very, very easy. So we actually fully documented everything we could to this point, including all our backend and staging processes. We have a full spec out on it, so if anybody's interested in using it, that they could figure it out and learn how to use it. We're going to put all future updates and videos and different things we work on here for use, so you can go there. You can also get it out of GitHub. It's been posted about an hour ago. And so you guys can download it. It was released for BSidesLV. It's my first BSidesLV, so we wanted to drop something nice. And then this will be a long-running project. So Will and I really like this. We've used it in an environment. We think it's really successful for our team. And so we'll be supporting it. We'd love to see Git issues. We'd also like to see pull requests and people to contribute.
We got stuff.
Yep.
Oh, he gave us the stuff. Cool. If you guys have questions, we can take questions outside, but I think we have to kick everyone out of the room in the next 2 minutes.
We do have.